you all. I know there is a lot of information which you need to process simultaneously, but I believe that with recordings which you have uploaded on YouTube, it will be easy for you to slowly move. And also, since my aim always is to make this course very comprehensive, uh, that's why we are providing recordings. And at the end of this course, like on 27th, which is the last day, fifth day, I believe that you all will be having some upper hand, some delta X amount of advancement in your uh, existing information about the remote sensing and EIE. So I can see 15 participants by now. I'll start. In meanwhile, can any one of you just uh, confirm me whether my slides are visible and my voice is audible?
Yes, sir.
Great. Then we'll proceed. Okay, so I wish all of you a very good afternoon. And first day we have seen the fundamentals of EIA, genesis of EIA. Then we have seen air environment. Then we have seen water environment. Now we will be seeing noise environment. Two, three more components are remaining that we will see on the during the further course of time. So now, in every part, when I describe you that what steps you need to follow for carrying out TIA, in this also we have certain steps which we need to follow. So in this case also our step one will be the identification of noise levels. Now you will be able to connect one by one. In most cases, first we always generate the baseline data. Then in step two, we will be describing the existing noise levels. What is the existing noise level? Then in step three, we will see what are the noise standards and criteria we need to follow. Step four will be prediction of noise levels. And step five, we have to give the noise control practices. This prediction part we will see tomorrow. Some part we will see tomorrow. Rest we'll try to understand today what noise is and how we have to proceed for that. So first we need to understand what noise pollution is. Slowly we'll understand. So there are two terms in this. One is sound and other one is noise. So if you see what sound is a form of energy which is emitted by a vibrating body and on reaching the ear causes the sensation of hearing to nerves. Okay, as soon as it reaches our ears, it will cause the sensation of hearing. Like I'm speaking, then it has been transferred from the internet to you and you are hearing. But it is not doing any disturbance to you because you are interested in the course and you are intentionally trying it. But when suppose there are some unwanted noise from my part or from anyone who has unintentionally unmute his mic. So then that sound will be called as noise. So noise is generally referred to as unwanted sound that can negatively disrupt human or animal life. Okay, so what what I would like to convey to you is that as far as it is sound, it is okay. But when that sound level is so high that it is causing any health impact to you, then it will become noise. Okay. Sound in such levels when it is causing health issues to you, then it will become noise. Now, the difference between sound and noise depends on these three things. As I already said earlier, habit and interest of the person, especially receiving it, the ambient condition, and the impact of the sound generated during a particular duration of time. Like if you are going to a party or a club, there even if the noise is more, you may be enjoying because you've gone with that interest and with the temperament itself. But if you are doing some work, if you are doing seriously some work and even a slightest sound is there, that will become noise. That is what the difference between sound and noise is. Now, if you see technically, environmental noise has been defined as any unwanted sound created by human activities that is considered harmful or detrimental to human health and quality of life. Okay, it has some detrimental impact on human health as well as on the quality of life. Now, uh, just like air, noise also has certain elements. Okay, so first there will be source, then there will be transmission path, and then there will be some receiver, which is us as human beings. So noise also consists of three parts only: the source of noise, transmission path, and receiver. Now, one thing you should understand that noise is also kind of air pollution only because the medium is air. Okay. Our human ears are always in the air only, whether we are sleeping or doing anything. Okay, so the medium of noise is air only. So many times noise is also considered as part of air pollution. Now, by now, this noise pollution was a underrated problem. Okay, it was often called as a forgotten pollutant also. Why? Because you can't see noise, you can't smell noise, and you cannot taste it also. That's why many a times it was considered as a forgotten pollutant, though it is a pollutant, but forgotten pollutant. Now, there are various reports which states that noise must be recognized as a major threat to human well-being. And let me tell you very honestly that noise pollution seriously plays a role. I'll give you one example. If you are living in an urban area, especially some of you, if you are from a metropolitan city, you observe your behavior and all other things, especially the thoughts going in your mind. Then you go to a hilly region where not much traffic and as not many people are there, you will see instant change. Why? Because there is no noise. As soon as you are returning to your place, you are returning to your city. As soon as you are reaching your urban boundaries, again similar behavior you will start to you will you will start doing the similar behavior because again the same noise. So it is an important part of any environmental study. We should give due respect that yes, noise is a pollution, and we should do something for it. Okay. Now, why noise happens? So, from a philosophical point of view, we can categorize noise as the chief product and authenticating sign of civilization. That means, as soon as civilization is going on, people are doing industrialization, people are constructing houses, people are running cars, people are running trains, there are metros. So, all this creates noise, and it is an indicator that yes, civilization is growing. Right, that's one point. But at the same time, it has adverse impact also, and that's what we need to address. So if you see what are the sources of noise pollution, first is that of course urban environment, specifically in that traffic growth. So there is a significant growth in the number of vehicles, which alone contributes 50% of the total noise in urban environment. And expansion of road network, if the road network expand, this also expand, and industrialization. So if you see, most of the noise will be from traffic and roads only. That's why any ambient noise will be on the road. But when you are doing EIA, mostly you will be doing for industry. So that time you have to carry out noise for industrialization. That also you have to keep in mind. Now we will see some technical aspects of noise pollution. So first thing is that we need to understand what a sound is. Then only we'll be able to understand how it converts to noise and in what units we measure noise. So sound. Sound is what? Sound is a manifestation of vibration travels in wave patterns through solids, liquid, and gases. Right, that is one part. The waves caused by vibration of the molecules follow sine function typified by the amplitude and wavelength or sometimes frequency. So you can see here, this is time and this is amplitude. The more high it goes, the more is amplitude. And this is period P. Okay, this is period P and this is pressure of the noise. So between these two consecutive crescendos, it will be period T. And what will be the frequency of noise will be? The number of wavelengths that appear to pass a fixed point in 1 second. Okay, the number of wavelength that appear to pass through a fixed point in 1 second, or maybe 1 second, 1 minute, any unit of time you can take, that is frequency. Okay. And one more thing what you need to understand is that sound waves of equal amplitude with increasing frequency from top to bottom. It is a sound wave of equal amplitude with increasing frequency from top to bottom. Now here you can see is that what amplitude is. Heights of the peak, which represents the pressure intensity and is related to the volume or loudness. Means it may be loud, it may be high volume, then this peak will go high. Okay, then this peak will go high. If it is low, then it will be like this, but sound will be there. So there are several examples of amplitude are given. Like there will be a low noise, but constant noise. That's why it is like that. Then there will be slight increase, and then there will be more increase in noise. That too for a particular period of time. So as soon as this peak increases, it shows the amplitude, means the high volume of loudness. So that is how you understand the noise in terms of frequency and in terms of amplitude. So suppose a person has shouted 2 times in 1 second or 2 seconds, then its frequency will be 2 shouts in 2 seconds, and that we will measure in terms of decibels. That I am coming to it. Now we will understand about the sound and human hearing. First, you need to understand that the speed of sound is different in different types of mediums. So in water, it is 1500 meter per second. In steel, it is 5000 meter per second, and in air, it is 340 meter per second. Now you see the highest velocity is in steel, but we don't. Our medium is air only. Very seldom we plug our ear to certain the different kinds of mediums. But the highest velocity of sound is in steel only. And as far as air is concerned, it is 340 meter per second. And one more thing what you need to understand is that we cannot hear sound whose frequency is below 20 hertz. That you have to keep in mind. Okay, we cannot hear sound whose frequency is below 20 hertz. And also, if the sound increases so high that its frequency is going above 20,000 hertz, then it will become pain. So our hearing will be in between these two range only. In this between these two range only we can hear. Okay. Now, how to measure this and how to report this in report format? So there was one scale which was developed. So the decibel scale was developed from this fact and makes numbers more manageable. Okay. The decibel scale generally ranges from approximately 0 to 130. So then we will understand now the frequency. I already told you that below 16 hertz, it is inaudible subsonic range. Then 16 to 20 kilohertz, it is audible sonic range. And above 20, it is again inaudible ultrasonic range. Okay, this is what our frequency is. Here it is 16, but usually it is 20 hertz. Okay, so you can you can assume nearby this 16 to 20 to up to 20 kilohertz. That is where human hearing can be done. That is where the sound will be audible. Otherwise, it will be inaudible. Now we will understand the acoustical properties of sound, especially the units of measurement of sound. So Graham Bell was a scientist. He only introduced this concept that if we measure noise in frequencies, we may not be able to make much out of it. So we should develop a scale or a unit which can be used for further decision making related to noise. So he developed decibel. Bell here denotes his surname, and deci means 10th part. Okay, I'm not going into the basics of it, but it is like he did the numbers in such a way that it is more manageable now. So what is a decibel is? A decibel is used to measure sound level. Decibel scale is logarithmic, and human ear respond to sound pressure in a similar logarithmic function. Okay, this makes the decibel an ideal measurement unit for working with sound. Okay, so there were a lot of research on it, and they have observed that sound propagate in logarithmic function. Okay, sound propagate in logarithmic function, which is very similar to what a human ear would hear. Okay, so that's why we are reporting the sound in decibels. Then this is dB. Okay, now I want to report it in terms of pressure level. Okay, so I have converted it as dBSPL. Okay, dBSPL, sound pressure level. And what does it do? It expresses the magnitude of volume or a sound. Okay, magnitude of volume or sound. Magnitude means its intensity, and magnitude we have heard already in previous classes. So levels in decibels are computed as L is equals to 10 log Q by Q naught. Okay, L is what? Sound pressure level in dB. Q is sound pressure being measured. What you are measuring using your sound level meter. And Q naught is the reference sound pressure, which is always 2 raised to the power 2 into 10 raised to the power minus 5 Newton per meter square. Okay, and the reference sound pressure corresponds to the lowest sound pressure a healthy human ear can detect. I told you already, it will be 20 hertz. So that 20 hertz, when it is converted to a pressure unit, it comes to 2 into 10 raised to the power minus 5 Newton per meter square. Okay, now sometimes we may have to convert it to some different units. Okay, so the intensity of sound is measured in sound pressure levels, and common unit of measurement is decibel. Okay, but the community ambient noise levels are measured in the A-weighted SPL, abbreviated dBA. I'll explain you what is A-weighted. Okay, so this scale resembles the audible response of human ears. Okay, sounds of frequencies from 800 to 3000 Hz are covered by the A-weighted scale. So now let's say if there is a sound pressure level L1 in decibels is measured at R1 meters, then the sound pressure level L2 in decibels at R2 meters is given by. Okay, L1 you know, R1, R2 you know, you want to find the L2. So you can very well measure this L2. L1 minus 20 log 10 R2 by R1. R2 and R1 are distances respectively for L1 and L2. Now suppose instead of dBA, it is now suppose the sound levels are measured in terms of uh, pressure. Then sound pressure level LP will be given by 20 log 10 P by P naught dBA. Means instead of distance, I will keep pressure. And P naught we will take as 2 into 10 to the power minus 1 Newton per meter square. I already told it. Okay, so this is how you can do between two distances also in terms of distance as well as in terms of pressure also. Now we have to see some noise indicators which will be useful for us apart from dBA. Okay, the first one is equivalent noise level LEQ. Okay, so first we need to understand what does the indicator means. A noise indicator or metric is used to reduce a large volume of information about a noise situation into a single number system. Okay, let's say you have a lot of noise pollution areas where you are measuring noise, but you have to report a single value. That you cannot report simply average because the noise moves in logarithmic fashion. I already told you it is in logarithmic fashion. So for that, you will determine LEQ. Now, what does LEQ means? It is probably the most common type of descriptor we use. You will see in further of my slides. It gives equivalent continuous noise level over a time period T. And what it is, it is the continuous steady sound level that would have the same total acoustic energy as the fluctuating noise measured over a time. Okay, you are measuring noise at so many places at different time. T1, T2, T3 time you are measuring, and you are having these values of noise at T1, noise at T2, noise at T3. So you will multiply it by 10 log 10 and you will divide by T. So you will be getting an equivalent continuous noise level. Okay, which will have the same acoustic energy as together all this will be having. Okay, then you can make a decision with a single number. I'll also give you an example. Suppose I have shouted at once at 1 p.m. Let's say 1 p.m. I shouted with my full capacity. Okay, that let's say has a acoustic energy of X. But then I have divided my intensity in 10 parts and I'm slowly speaking 10 times, which will also have a same acoustic energy. So the average, the logarithmic average of all this will be a LEQ, equivalent continuous noise level, because it will have the same acoustic energy. Here LEQ is equivalent continuous noise levels. T1 is time at L1 hours. T2 is time at L2. L1 is sound pressure level which will be measuring, and T is the total time at which LEQ is required for how many hours you want to see. Okay, apart from that, there are two more indicators which we require. Okay, the two most important indicators apart from LEQ is L10 and L90. Now, these are very important. You should understand this. When I say L10, 10 is representing a certain percentage. When I say L90, N90 is also representing certain percentage. Okay, now what does it mean? L10 represents the noise level exceeded for 10% of the time. Okay, suppose your monitoring period was 1 hour. Okay, 1 hour. In 1 hour, there will be 60 minutes. Okay, in 1 hour, there will be 60 minutes. And when I say 10% of the time means 6 minutes out of, okay, 10% of 60 will be 6. All right. So 6 minutes, the noise was more than 65 decibels. That is what L10 represent. Okay. L10 1 hour means when I'm saying that L10 1 hour is 65 dB, it means that for 6 minutes, 10% of the time noise level exceeded 65 decibels. Then of course, what does L90 will mean? L90 represents the noise level exceeded for 90% of the time. Same case only means if I say L90 1 hour is L90 1 hour is 60 dBA. Okay, 60 dBA. So we can say that 90% of the time means 54 minutes. 54 minute noise was greater than 60 dBA. Okay. Now this L90 is also known as background noise level. This is also known as background noise. Why it is called as background noise? Because there will be some noise always. Always some noise will be there on road and any places. But sometimes the noise will be exceeding the other noise which are prevalent in that place. So that's why 90% is also called as a background noise. I will give you the real life example of this. Long back, I was working on a case given by NGT to CSR Miri Nagpur. They were constructing one bridge in Mumbai, and the nearby occupants has lodged a complaint against the company that the construction of the bridge is quite annoying to them, and there are high levels of noise. Then that case was awarded to NIRI. I also gone to site. We have visited the site and we have measured the noise levels, and we found out that construction was only contributing 5 to 10% extra, but 90% of the time the noise was already in the high range. So background noise was already there, but because the construction started, the extra noise was annoying to the people, though they were very habitual of the already existing noise from the roads. So that's how we gave the report, and the complaint was discarded by the court that since background noise is already there and construction is a temporary activity, it will be over in 1 or 2 years. You can do some of your measures. You can put earbuds or any of the things. So like that, you can understand that these kind of indicators are quite important. And same thing you will apply in EIA, because EIA, when you are going for baseline data, you should not say that whatever construction is going on for this industry, it only will create noise. There may be traffic, there may be nearby some temple or some mosque or church or any religious place or any such place which generate noise. So those kind of cases, you have to include those things, and then you have to arrive at a conclusion. Now there will be one day-night equivalent noise level also. So you have to keep in mind that when you work in noise pollution, the daytime is considered as from 6 a.m. to 10 p.m. That is for 16 hours. And night time is considered as 10 p.m. to 6 a.m. That is for 8 hours. So if suppose you have values for both the time, you have LEQ for night and LEQ for day, then you can convert both the things with using a one formula, LD and DB. Day-night equivalent noise levels. 10 into log 10, 16 by 24, this term. 8 by 24 this time, 8 by 24 because this is for 8 hours, 16 by 24 because this was 16 hours. Okay, this is called as LDN. And one important concept what I want to show you is that always keep in mind that when you are working in noise pollution, there will not be a direct addition or there will not be arithmetic addition of numbers because it works in log scale. I told you already. So here you see when there is a noise of 57 decibels and there is a noise of 63, again there is a noise of 63, then 63, then 69. So when I'm adding these two sources of 63 and 63, the resultant will not be 126. It will be 66 decibels. Okay. And if I'm adding this 66 and 66 decibel of noise, the resultant will be 69 because most of it will be cancel out. Noise will be cancel out. And if I'm adding 57 and 72, the higher noise will prevail, 72. Okay, because higher noise anyway it will prevail. Okay, so you have to keep in mind that the addition of sound levels will be different. Okay, the addition of sound level will be different. Now I'll explain you about the weightage criteria. I told you that I'll explain you later on. So what does the weightage criteria is? There are three weighting criterias, weighing criterias, A, C, and B. A is the criteria which adjusts overall scale so it better matches with what the human ear would hear. Okay, it is for the human ear. C is for C adjusts scale for loud or low frequency sounds in which the sound is loud. And B adjusts the factors that are in between the A and C. Like suppose you are working in a factory where there is a impulsive kind of sound like some hammering or some other kind of work. In that cases, B we can use. So this weighing what it will do, whatever noise you are taking, it will do some correction in it and it will reduce the value in such a way that it will be a practical application of what my human ear would hear. Okay, I'll give you an example. Suppose you have put a noise meter near the road, but your house is 3 meter after it. One thing. Second thing, human ear will always be at a certain height always, right? It won't be at the ground, right? So looking to these two, three things, the A weighing criteria will correct the noise in such a way that it will be a true representation of the measurement. Okay, like that weighing skills will go. Now, if you want to measure noise at site, you will require a sound level meter. Okay, with the sound level meter only, you will be able to measure noise. So there are four types: type 0, type 1, type 2, and type 3. Okay, four types of noise meters. Type 0 is used for laboratory reference and standards. Type 1 is used for land use and field use in specified control environment. And type 2 is the general field use when you are using you doing ambient noise monitoring. And type 3 when you want to do a long scale survey, which more storage and all, there you will use type 3 kind of equipment. Sometimes there will be impulse meter also for measurement of impulse noise like hammer blows, punch press stroke, this kind of industry. You will use frequency analyzer also for detailed design and engineering purpose using a set of filter. Okay, sometimes you need to do frequency analysis also. Graphic recorders, noise dosimeters. This you use when you want to know how a person is exposed to noise. So you will put this noise dosimeter on the cloths of that person and it will be recording noise continuously. And calibrators, as we all know, for checking the accuracy of sound level meters. Now, one thing you need to keep in mind that this is all because of the exposure to human being. Okay, why we are measuring noise is that because after a certain range, if you are continuously exposed to the noise, your ear capacity of hearing the noise will be reduced. Many times you would have observed that in your home, some elderly people and all, they are watching TV for 6 months to 1 year on a louder volume. Then naturally, if you want to say something, you have to speak a little bit louder to them. Why? Because that the human the ear configuration itself has adapted to that. That's why there are certain ranges based on the health aspect that not we should not avoid. while working in noise pollution area. Certain exposure only we should give. Okay. Now, if you see the noise, sources of noise, it can be categorized into just like air. Outdoor air pollution, indoor air pollution. Here also it will be outside or inside. Outside, road traffic, train, airport and aircraft noise, construction, industrial noise, stationary sources. There may be some stationary sources like industries. And inside we have some home appliances like mixer grinder and all those things, TV, radio, our mobile phone, and some kind of power tools for drilling, milling, and other things. These are the sources of noise. Now we will just see the direct effect of noise on our health. So first thing is that primary exposure, if you are having to noise, it will have three acute effects. First, your sleep quality will be decreased, right? Then there will be increased noise and stress, and there will be temporary change in hearing immediately, because instantly you may not be able to hear. Then there will be some chronic effects of noise like hypertension, then reduced learning and productivity and endocrine disruption. And this together in long term, this will lead to heart disease and permanent hearing loss and tinnitus. Tinnitus, I will show you what it is. Okay. Now, after that, there are two more things which we need to understand. There will be two types of loss if you are hearing noise in a if you are in an environment which is too noisy. First one will be TTS, temporary threshold shift. Second one will be NIPTS, noise induced permanent threshold shift. So in temporary shift, there will be temporary hearing loss. Let's say approx 1 month or something, you are not able to hear. Like I'll give you example. Recently, I visited Lakshadweep Islands. There I did scuba diving. There was no sound, but when we went to 10 to 12-meter height, the water pressure was so much that through my right ear, I was not at all able to hear for almost 1 month properly. So I was, someone is saying I was trying to hear to them like this. So that is also pressure only. Sound is also pressure. That is also pressure, but that pressure was because of the water. And similar cases with the TTS and NIPTS. Okay. So some of the things which you need to understand is that if the noise is less than 80 dBA, there will not be any hearing loss. If the noise is between 80 to 130 dBA, there will be TTS, temporary wala. And if 50% of people exposed to 95 dBA will experience NIPTS, permanent hearing loss. Means if 100 people are exposed to 95 decibels, 50% will lose the hearing capacity. And if it is 150 dBA, for sure it can physically rupture the human eardrum. And if you are exposed to 1 hour for 100 dBA, it can produce TTS. And if you are exposed to 8 hours of 95 dBA, over 10 years may cause NIPTS. Okay. And of course, if it is about 10,000 microbars, it can immediately do the physical damage to you. Okay. Now, second one is cardiovascular disease. So what happens is that when we are exposed to high quality of high levels of noise, it changes in our blood pressure, and that blood pressure and other things collectively causes problems in our heart. So that's why people are suffering from ischemic heart disease. Okay, ischemic heart disease, and also it can increase stress in our arteries also. So that is also a one point. Now, I would like to draw attention to a disease called tinnitus, and I'm sure many of you would have encountered it by now. You would have seen that in our houses or in our friends who do such kind of jobs which require a constant phone call, and their phone continuously rings. Many times they feel that their phone is ringing, but actually it is not ringing. Right? Many times they will feel that their phone is ringing, but actually it is not ringing. That is a disease. That is a disorder, and that is called as tinnitus. Okay, because we are so merged in that even without ringing the phone, we will hear that yes, my phone is
हेलो
ringing. And hello, yes,
मैंने तो दी नहीं
okay,
है यार, मैंने तो ऐसे ही सबमिट कर दिया यार। कहाँ लिखोगे?
okay. So now we will see further. I hope you understand the tinnitus, and it will be very irritating, and sometimes it will be awkward also that my phone is not ringing, but still I'm checking this phone, and people are thinking like whether I have gone mad or not. So that also you have to keep in mind. Of course, there will be disturbance of sleep pattern and sleep quality. Also, I have already explained you in brief that if you are exposed to noise, there will be a serious impact on human performance as well as on your nervous system. Now, as far as animals are concerned, there are serious effects on animals also. Okay, if suppose there is too much noise, then that birds will migrate to a different place. Now, you would have heard from your grandparents or someone, if you are living in your ancestral house, that 20, 30 years before they used to say a flock of birds roaming around their house. Lot of other things they used to see, butterflies they used to see, but now it is not there. So of course, other pollution is there, but noise pollution is also one of the factors. That's why they migrate to places which is conducive to them. And also zoo animals like deer, lions, rabbits, they will become dull and inactive, and their health also deteriorates. And at the same time, too much noise affects food habit as well as the mating behavior in birds and animals. And not only that, nowadays these ships and other things which make siren for for navigation of different purposes. It has been found that it has a direct impact on the aquatic life also. And siren and all are one part. The propeller, which is below the ship, which constantly make noise in water, it very fast reaches to the aquatic life, because you know that in water it has the velocity which is almost 10 times higher than air. One thing. Second thing, they have their own communication modalities between the fishes and this aquatic life. That also hinders because of that. So that is also a one part. Okay, now I would like to draw your attention to some of the rules and regulation of noise. So in noise pollution, we follow noise pollution regulation and control rules, uh, regulation and control rules 2000, which was amended in 2010. One more amendment is there 2024, but that is not very important to us. So in that case, they have divided the area in four types: ABCD, that is industrial area, commercial area, residential area, and silent zone. And for daytime, they have given some value. For nighttime also, they have given some value. This noise should not exceed these values. Okay. Then there is one motor vehicle at 1939. It prescribes noise limit for different types of vehicles like motorcycle, scooter, and three-wheelers. It should be within 75 to 80. Passenger car 75. Passenger or commercial vehicle up to 4 metric ton 77. 4 metric ton to 1280, and above 12 metric ton 82. Okay, then there is one Factories Act. If you are working in a factory where there is continuous sound, then there is exposure area which is given to you. Let's say a peak sound pressure of 140 is there. So permitted number of impulses or effect per day is only 100. More than that, it should not be there. So 100 impulses of 140 decibels. Similarly, if it is 135, 315 can be allowed, and so on. Then there is a time, there is a limit based on the exposure time also. So suppose if you are working in a factory, many times we may not many times, most of the time we have to follow the Occupational Safety and Health Administration, OSHA regulations. It is called as OSHA regulations. So suppose if the sound pressure level is 90, if the sound pressure level is 90 dBA, then the total time of exposure, okay, continuous or a number of short time exposure per day in hours should not exceed 8 hours. Means for 8 hours, he can bear 90 dBA, but then it should not exceed. For 6 hours, he can bear 92. For 4 hours, he can bear 95. So if the noise is increasing, as you can see, the exposure time is decreasing. That is what we need to take care. Okay. And in any case, no exposure in excess of 115 decibels dBA is to be permitted for the people working in your factory. Okay. So with this, I finish the session on noise pollution. Modeling part we will see in the case studies. So if there is any doubt, I would like to answer a couple of questions. Otherwise, you can proceed with the QGIS hands on, and you can put your doubts on the group.
Sir,
Yes, Siddesh.
sir, I didn't understand the noise metric part.
Okay. So uh, I will make you, I'll explain you. Suppose okay, before that, do you understand up to that point where we need to go to site and we have to measure the noise?
Yes, sir.
No. Suppose you have done some noise pollution monitoring and now you want to make a decision out of it. So in noise pollution, we have two important matrices which we use. One is L10 and one is L90. This is apart from LEQ. LEQ anyway it was there for continuous sound continuous noise equivalence level LEQ. Apart from that we use L10 and L90 also. So here L10 means 10 represent the percentage. Okay. And if suppose I am saying that I have gone to a site, I have measured the noise for 60 minutes. It may be any duration. For example, let's say I have measured the noise for 60 minutes and my L10 60 minute is 45 decibels, 45 dBA. Okay, so uh, I will interpret it like for 6 minutes, it is 10% of 60 minutes. My noise pollution was more than 45 decibels. Okay, that is what L10 means. And if it is L90, same thing, all things same, but 90% of the time of 60 minutes, which will be equivalent to 54 minutes. So we can say that for 54 minutes, my noise pollution levels was more than 45 dBA. That is one part. I hope up to this point is clear to you noise metrics. Second thing, you would have heard that he is a gate percentile of 12% or 98 percentile or 99 percentile, minimum 100 percentile is required. So percentile means it is not percentage. Okay. Percentage you calculate when you are including all the candidates who are appeared in the exam. But percentile you see from a particular cutoff point, right? From a particular cutoff point, that this is the minimum cutoff criteria for passing this exam. Now, out of this, how much mine is percentile? Similar is this one only. L10 and L90 are nothing but 10 percentile and 19 percentile. And the calculation part will also be same. You have to first arrange the noise pollution data in increasing order. Then you have to go to the 10th one. Then you have to apply the formula for percentile and you have to calculate. So I hope it is clear to you, Siddesh.
Yes, sir. Thank you.
Welcome. Anyone else? What are the methods to assess the noise pollution in area? Actually, I showed you in one slide. Now there are noise meters for that, and there are four types: type 0, type 1, type 2, and type 3. So for field condition, we use type 2. Type 2 instrument, which is for field survey. And if it is a long-term survey, we use type 3. It is based on a noise pollution meter only. And if you need something else, you can ask me by methods.
Hello, sir.
Hello, yes.
Sir, the permissible noise levels are similar for residential or non-residential area or any other type of areas.
No. It is not similar. It is different. Different means it is specific. I'll show you again. This one, na? So residential means a residential only. There, I should not mix any other thing. Of course, in India, it is different because in India, it will be like downstairs one shop, first floor they themselves are living, and after 4 building, there is one small hospital also. And after 4 building, there is some small MSME also. But ideally, it should not be like that. In India, we have mixed land use. But when you categorize, the categories are completely separated and excluded. Residential area means residential area, no other activity. For that, limits are like this. And already I showed you that for factories and all different acts are there. For motor vehicle, this one, factories, this one, and for other factory based on the exposure hour, this one.
Okay.
Anyone else? If there are no questions, then we'll wind up the session. But my request to you will be that you please keep doing the hands-on on QGIS. It is a rare opportunity that you will learn something from. Concept of noise modeling, it will be there tomorrow. GIS based noise modeling, I'll be showing. Okay, once you have finished the accuracy assessment and all, tomorrow in first half, second half, tomorrow and day after tomorrow, all only applied part only. Basics we have done. Some basics are remaining, but that won't take much time. But okay, then have a nice day. Keep doing and please put on the group.